In part 2 of lecture 8, we will discuss building an abstract syntax tree. Let's go through the process of building an abstract syntax tree for the statement z is set equal to 2 times x plus y. The first production in the grammar is s derives id, push identifier is set equal to push assignment, e, build assignment. We get past the initial identifier, and then we have the action push identifier, and that's exactly what we do. After we reach the terminal assignment operator, we next encounter the action push assignment. This is not a push in the normal sense of the term. What we will do here is we will pop the identifier, add it as a left child to the node with the assignment operator in it, and that together will be pushed on the stack. Now we encounter the token constant. We are up to the non-terminal expression, and the constant together with the non-terminal expression will give us e derives te prime. We now are looking to parse the t, and again, given constant, we have t derives ft prime. And now we will look to parse factor. Factor derives constant. We take the constant. We now have the action push constant, and we will push it on the stack. Now that we have gotten past the factor, we have the t prime. The t prime together with the asterisk will give us t prime derives asterisk, push up, f build term t prime. Having gotten past the asterisk, we now push the operator on the stack. As we saw before with push assignment, we will pop the constant, create it as a left child of asterisk, and that tree fragment will now be pushed on the semantic stack. We are now up to the f after pushing the operator. The identifier together with factor will give us f derives id push id. We take the identifier and it gets pushed on top of the stack. What you see here is another look at what we had before. F derives id push id. We see the identifier on top of the semantic stack with the two tree fragments below it. You can also see here the identifier in question in our parse tree. What we have on the semantic stack are a couple of various tree fragments. These will be put together to create a tree in due time. Having already found the factor, we now are at a point where we are looking to build the term. What that means is that we are going to pop the identifier, we're going to pop the tree fragment with the asterisk and the constant, and identifier will be the right child of the asterisk. Having dealt with the factor, we will now be dealing momentarily with t prime. We have t prime on one hand, and the next look-ahead character is the plus sign. What that will give us is t prime derives the empty string. You can see now where the plus sign will fit when we move on. We are now finally ready to deal with e prime, which will be, in this case, e prime derives plus push up, t, build expression, e prime. The push up means that we will end up popping the tree fragment with the asterisk at the root. This will become the left child for a new tree fragment with plus at the root. Having gotten past push up in e prime, we now are looking at a term. That means we're looking at t derives f, which means we're looking at f derives identifier. Having found the identifier, we now push it onto the semantic stack. Having gotten by the factor and the term, we're now ready to build the expression. What this means is we pop the identifier, we pop the tree fragment, and identifier becomes the right child of the tree fragment with plus at the root. Having gotten by the factor and the term, we're now ready to build the expression. What this means is we pop the identifier, we pop the tree fragment, and identifier becomes the right child of the tree fragment with plus at the root. At this point, we have completed the expression. We have gotten by the final e prime, which derives an empty string, and we're ready to build the expression. We pop the tree fragment with the expression. We pop the tree fragment that has the assignment operator as the root and as left child the identifier. And then we take that tree fragment and it is the right child of the assignment operator. In this regard, we have completed the process of building the abstract syntax tree.